Alright, this is 10.2. This is the notes for 45, 45, 90 degree right triangles. And these are special cases, and this pattern makes it very easy to find the missing sides without having to use the Pythagorean theorem and only having one out of the three sides instead of having two out of the three. The 45, 45, 90 degree triangles, they look like the examples that are down here. So there's two 45 angles and a 90. Because these angles are the same makes it isosceles, and because it's isosceles, the definition for isosceles says that two sides will be the same, so the two legs will be the same on this right triangle. These legs will be the same on this right triangle. These legs will be the same on this right triangle. So because of that, like down here where it has this side that we don't know what it is, because they're 45 and 45, these angles are the same, these sides are the same, that's going to be a 4 also. If you wanted to, you could use the Pythagorean theorem with these two legs and find your hypotenuse, but there's a pattern that makes it much easier. So the theorem, the pattern, says that in these right triangles, the legs will be the same, and then the hypotenuse is going to be the leg times the square root of 2. So if this is 4, then this is just going to be 4 times the square root of 2. If you need to find the decimal, you can put it in the calculator and it'll give it to you. You can round to the nearest tenth. But if it doesn't say you need to give me a decimal answer, you can write it like this, and that's all you need to do. Right here, same thing. If this is 9, this other leg would be 9 also. This hypotenuse would be 9 square root of 2. On number 3, if this is 45 and 45, again it's isosceles. These two sides are the same. If that's 17, so is this side. The x that we actually care about, though, is going to be 17 square root of 2. Now, when you're going in reverse, you're going to, instead of multiply, divide by the square root of 2. So if you have something that has the 3 square root of 2 for the hypotenuse, or 6 square root of 2 for the hypotenuse, or 11 square root of 2 for your hypotenuse, to get these legs, you're going to divide by the square root of 2. So if you have 3 square root of 2, you divide by the square root of 2, then these will cancel, and x is just going to be 3. So over here, if this is 6 square root of 2, and you're dividing by the square root of 2, this leg is only going to be 6. The other leg would also be 6. Over here, if this is 11 square root of 2, if you divide by the square root of 2, this leg would only be 11. If you have something that doesn't have this square root of 2 that's ready to be canceled, then if you're trying to simplify it, simplifying radicals, you cannot have a radical in your denominator, and so you would have to do more work for it. But if you're doing it to the nearest tenth, the calculator is going to take care of dividing by the square root of 2 for you. So like right here, that's the hypotenuse. You'd be dividing to get the leg, so you would go 20 divided by the square root of 2, and your calculator is going to do all the work for you. So 20 divided by the square root of 2 is 14.1. So x would be 14.1. So being that I'm only asking you to give me the answer in the nearest tenth, the calculator is going to do the part that would be a little bit tricky for you. Over here, same thing. You would divide 8 divided by the square root of 2, because you have a hypotenuse and you're looking for a leg. Divided by, almost forgot. So 8 divided by the square root of 2, I get, that's my answer, 5.7. And remember, I'm going to rewrite this. 8 divided by square root of 2 is how I got that. Number 9, oh, that's the hypotenuse. So again, I would divide. So I'd go 35 divided by the square root of 2. On the calculator, 35 divided by the square root of 2. I get 24.7.